Hello everyone. So today we are going to see another question which is miscellaneous type. Okay, nothing specific to pattern like if this pattern then monotonic stack, but a good question of monotonic stack. Uh, so the question says that there are n cars at given miles away from some starting point which is 0 and they are traveling to reach the mile target. Now you are given two integer arrays, position and speed, both of length n, where position I is the starting mile of the ith car and speed of I is the speed of the ith car in miles per hour. A car cannot pass another car, but it can catch up and then travel next to it at the speed of the slower car. So if the car matches some another car who is traveling at faster speed than it at certain point, then both of them then both of those cars will travel at the same speed, which is the lowest of both of these cars. Okay. A car fleet is a car or cars driving next to each other. The speed of the car fleet is the minimum speed of any car in the fleet. If a car catches up to a car fleet at the mile target, it will still be considered as part of the car fleet. And we have to return the number of such car fleets that will arrive at the destination. Okay. So let me give you example and then it will be better for our understanding. So this is the example. The example says that there are five cars. Okay, starting from 10, 8, 0, 5, and 3, and they have such speeds. Okay, so first 10 car will travel 2 speed and it will reach 12 in 1 hour itself. 8 have speed of 4, so that too will reach 12. 0 will have 111 speed, so in 12 time with 111 speed, in 12 seconds it will reach 12. 5 in 1 second, in 1 hour it will have 6 speed, it will reach at 6 point, and then again 111 and so on, and it will reach 12. 3 at the speed of 3 it will reach 6, but then this 2 will combine, so they are in the one car fleet, and then they will travel at the speed of 1 only, which is the minimum. Okay, and then they will traverse ahead until the end point. This two also will be a group. This will reach separately, this will be reaching in a group, and this two will merge or meet at some point, and then they will travel at the same speed of 1, which is lowest, and then also they will reach at 12 at certain point. So there are total three groups which will be reaching the 12 point. Okay, so there are total three car flits. I hope you now got what is the car flits. Okay, so the answer of this is 3. So there are total 3 car flits which has happened, 3 groups which has happened. That's what the meaning of it. Okay, so now again your position is given as, okay, there is no pattern of this that you will get that okay, monotonic stack only you have to use, but at least what you can do in starting is, okay, you are given 10 positions as 10 8 0 5 3. So 10 8 0 5 3, and you will be given speed also, which is 24113. 24113. Okay, so these are the two given things, position and speed. So at what time it will reach, that you will be able to calculate. First thing is, can we sort this? Why? So that we can understood that we will sort it on position based. Okay, that who is starting first. Okay, let's just sort it in the position based. So let's say we have sorted like 0 3 5 8 and 10. Okay, and then its corresponding speed is like, for 0 it's 1, for 3 it's 3, for 5 it's 1, for 8 is 4, and for 10 it's 2. Okay, now at what time they will reach? So if I have to calculate the time, what I need to do, so let's say my target is 12 and I'm currently at 0, so 12 minus 0 divided by speed is 1, so in total of 12 seconds I'll reach, 12 hours or 12 seconds or 12 minutes, whatever. For this 3, my I have to reach 12 minus, I'm currently at 3, divided by the speed is 3, so 9 by 3 is 3, so in 3 hours or 3 seconds I'll reach the point 12. So time is nothing but, in how much time it will reach is target minus position of I divided by speed of I. Okay, so this will be 12, this will be 3. 12 minus 5 is 7, divided by 1 is 7, 12 minus 8 is 4, divided by 4 is 1, and 12 minus 10, 2 divided by 2 is 1. So this 2 will reach on one time, this will reach on 3, this will reach on 7, and this will reach on 12. Now our main question is, will any car blocks other car? Blocks in the mean, will it block any other car, or will it catch up some other car at certain point? So okay, this is anyway slow, okay. This will be reaching fast at 3 time, and this is reaching slow at 7. Okay, are there any chances this two meet? Okay, the speed of this car is 3, and the speed of this car is 1. Okay, the speed of this car is 3, and the speed of this car is 1. So it will take more time to reach, okay, with lesser speed. At any certain point, this car 3 will block the 7, or 7 will block the 3. 7 will block the 3. How could I tell this? Because 3 has highest speed, it will reach in smaller time, but it has some number who is traveling in less time. So there are high chances that this will block this car. This will certainly block this car because its speed is low, okay, and the speed of car 3 is high. Okay, at certain point, this one car will hit the 3. Will hit the 3. So all those cars which has lesser the speed than 7 will hit 7 at certain point. That's what I could say from this. Okay, that's what I could say from this. At any point, because this is the floating time. Okay, so at any certain time they can meet, not in the integer time period only. At any certain time they will meet for sure. They will meet for sure. Okay, let's say the array is like this. Okay, this is lowest. Okay, is there anything higher than 10 on this side? No, nothing higher than 10 on this side. So it will reach on its own only. It will reach on its own only. For this 9, is there anything higher on this side? Because this sides are cars starting from later stage. Okay, no, for 7 also nothing higher than this. For 3, 5 is higher than this, so this 5 might block 3. So there are total 4 car flits which you can say out of this. So this is nothing but 10, 9, 7, and 5. This monotonic decreasing stack is what you will feel. I'm not sure if you got my point or not. Okay. Let me take another example to make it better. Let's say you have target as 100. Okay. Your position is 0 to 4 and speed is 4 to 1. Okay. Position is 0 to 4 and speed is 241 or 4 to 1. 4 to 1, sorry. Speed is 4 to 1. Okay. So how much time it will take? Let's just calculate the time, because position is already in the sorted order. So time it will take is, for 0 to reach 100 is 100 minus 0. 100 divided by 4 is 25. For this 100 minus 2, 50. 50 divided by 2 is 25. For this 100 minus 4 is 20. Okay, for this it's 25, 25, 25 only. So only one flit will be there. Fine. Let us take another example, which I have to create. And let's say time is 16. And your position is 0, 2, 3, and 5. And your speed is, let's say, for 0 it's 1. For 2 it's 1. For 3 it's 5, and for 5 it's 2, let's say. Okay, so the 16 minus 0 divided by 1 is, so time is actually 16 minus 0 divided by 1 is 16. 16 minus 2, 8 divided by 1 is 8. 16 minus 3, 13 divided by 5, which is what? 5 2s are 2 point something I would add. So let's say 2.3 I'm writing. And this is 16 minus 5 is 11 divided by 2, which is 5 point something, 5.6 or something. Let's say. Okay. Now, there is nothing higher than 16 on this side. So this is actually traveling at very slow speed. Okay. This is actually traveling at very slow speed. No one is no one is slower than this car. That's what I could say. That's why only it is taking longer time. Right? No one is slower than the 16, and that's why it is very slow. So it will take full time to reach. Right? So no one can beat this no one can beat it. For 8, still no one is slower than 8 on the right side. Okay, so this will also slowly reach at its point. No one can beat. For 2.3, yeah, there is another car slower than 2.3 on the right hand side of this, which will block this 2.3 at some point, for sure, at some point. Which point, if you need to find, then this 16 is traveling, this for position 3. For position 3, it's traveling at speed of 5. So 3 plus 5 is 8, let's say. 5 plus 2 is 7. This is for the first time. Okay. Next time, this is increasing by 5 points in 1 hour. So this is 8 plus 5, 13. And this is 7 plus 3, 10 only. So at certain point between 10, 11 and 12, this has matched. They have came to certain point. We didn't have to find any integer point only where they will meet. No, after 1 hour, after 2 hour, no, they can meet at 1.5 hour also, they can meet at 1.25 hours also, they can meet at 1 hour and 2 minutes also, anything. So if you find any speed, any time which is greater than this, which is slower than this, then for sure it will block and you will get it. So now what you have to do, now what you have to do, it's nothing but what you are finding is for 16 nothing. For 8, nothing. What you're finding is next greater elements, right? For 16, the next greater element is nothing. For 8, the next greater element is nothing. For 2.5 is 5, it's 5.6. For 2.5, it's 5.6. But is finding next greater element helpful over me over here? Like 5.6, I'm getting here also. Is it helpful to me in this case? Okay. How the stack is filled in this case, how the stack will be filled in this case. So initially 16 is there in the stack. Sorry, for the next greater will be traversing in the opposite direction. So 5.6 is there in the stack. Now I need to find the next greater element. Okay, so I'll remove all those which are smaller. So for 2.5, no, I won't remove, I'll just add 2.5. Now when 8 is coming, I'll remove 2.5, I'll remove 5.6 also, and I'll import it. And when 16 is coming, I'll remove 60. So only one one is there in the stack. Okay. What if I'm doing previous greater? My point is again 16, 8, 2.3, 5.6. Okay. What if I'm finding previous greater? So for 16, nothing. For 8, when 8 is coming, with previous greater. So I'll remove all those smaller than equal to 8. So 16 is not smaller than equal to, I'll push 8. For 2.3, again, I'll push. For 5.6, I'll remove 2.3 and I'll push 5.6. So I'm getting monotonic decreasing stack in this way. Now, my target is not related to next greater element or previous greater element. No, I need to find the monotonic decreasing stack. I have to find the monotonic decreasing stack, skipping those values from the in between, which has higher speed than one on the right hand side. And that's why I'm using previous greater element algorithm, but I'll not store it in the vector, the previous greater element of 16. The only point I have to do is I have to store it in the stack. I have to store it in the stack. Okay, let's just solve the question now in the window. Okay, so we have int n as position dot size. we have to sort it. So we will store the pair as cars of size n, and for int I0 I less than n I plus plus, cars of I is equal to position of I and speed of I. Okay, now I can sort this car because I want to sort it according to the position. So I'll sort. Okay, now this will be the pure floating values. Okay, so we'll have one float vector of time of size n. We will traverse, and then time of I is equal to target minus position of I, this cars of I dot first into 1.0 divided by cars of I dot second into 1.0, and this fully will be under the brackets. I hope I'm clear with this floating values. Okay. Okay. Now you have one stack again of float only, and you will traverse in the forward direction itself. What you will do, while not stack dot empty, previous greater element algorithm you have to apply, because I want my stack to be decreasing, right? Why decreasing? We have seen and stack dot top is less than equal to time of I. If that is the case, I'll pop it out and I'll push the time of I inside this. Okay, for the better understanding we can multiply 1.0 here also, but anyway stack is float still. And now we have to return just what? The size of the stack, that are the total number of flits which is possible. Okay. Fine. So this is the miscellaneous kind of question, which you'll realize after certain point that okay, I have to find monotonic decreasing stack in this way, and so I need to use the monotonic stack over here, not for the next greater or previous greater or any such algorithms. Okay, I'll post similar kind of questions over here, and through this we have completed monotonic stack playlist. I'll post some new questions in the description that you can try and solve, and next I'll be covering a new topic very soon. So stay tuned until that. Do like, share, and subscribe if you have learned a lot out of this. Stay tuned, stay safe. Bye bye.